Hello everyone. Today we will talk about functions. Today we will talk about functions. What function is? It forms a most important building block of mathematics. It is derived from the word meaning operation. It is derived from the word that is operation, word meaning operation. So in this we will deal about the different kinds of function. Is also a different kind of a special kind of relation. It is a special kind of relation. So we will first see the definition. What definition of function is? Let A and B be two non-empty sets. A and B be two non-empty sets. A relation F from A to B, that is a subset of A cross B, is called function from A to B if for each value of A, for each A belongs to A, there exists B that belongs to B. So what we will definition is, if there are two sets, non-empty sets, that is A and B, and there is a relation from A to B, that is a subset of A cross B. All the subset of A cross B is called a function of A cross B if and only if A is a subset of A, then there is a subset of B which belongs to subset B. So first we will see one example. Let A is equal to 1, 2, 3 and B 2, 3, 4 and F1, F2 and F3 be 3 subsets. Of A cross B such that it is given as function F1 is contain the sets 1, 2, 2, 3 and 3, 4. F2 contain the sets 1, 2, 1, 3, 2, 3, 3, 4. And function F3 contain the sets 1, 3 and 2, 4. F1 is a function from A to B and F2 is a function, but F2 and F3 are not function of A. F1 is function from A to B as we see, but F2 and F3 are not functions, since in this there are element 1, 2, 1, 3, 2, 3, 3, 4 and F2 is not a function from A to B because 1 belongs to A has two images too, as 1 belongs to A. It has two images, that is 1 belongs to 1, 2 and 1, 3. If a function has 1, then it is only has a free image in that one function, so this is not a function from A to B. Similarly in F3 is not a function A to B since 3 does not belong to A. So in this way we can compare the functions. If we have to find the domain and the range of this, so domain of F is equal to A that belongs to AB and then belongs to, and range of F will be equal to B that belongs to AB and that belongs to function. So these are the range. The first elements, that is 1 in this function, the domain is 1, 2, 3. In F1, if we see in F1, domain is 1, 2, 3 and range is 2, 3 and 4. So these are the domain and the range of the following function. Let's move to the second question. In this it is given that if xy belongs to 1, 2, 3 and 4, then which of the following then which of the following are functions in the given set? We have to find which of the following is a function and which of the following function. First one is f of a that belongs to xy, where y equal to x plus 1. So in this we have to check that which of the following is a function or not. So in this first we will check, if we make the function f1, then y is equal to x plus 1. When we put x equal to 1, then we get y equal to 2. When we put x equal to 2, then we get y equal to 3. When we put x equal to 3, then we will get x equal to 4. Then y equal to 4, and we would put 4 y x equal to 4, then we will get x y equal to 5. So at 1, 2, 3 and 4 we get the images, different images of the different elements. So this is a function. In this what we get, this is a, let's move to the next part. We have to check function 2 is a function or not. As we say, the element 4 of appeared in the first place of ordered pair of f1, that is 4 f appeared in the first one. F1 is not function of itself, so this is not a function. Next we will check, let us given f2 and it is given that xy belongs to x plus y that is greater than 4, and we have to check that it is a function or not. Let's make the set f2 first. If we put x, we have to put x and y. So f2 will be equal to, when we put x1 then 4, set 1. If we put 4, then we will get 1. If we put 2, then we will get 3. If we put 3, then we will get 2. If we will put 2, then we will get 4. And if we will put 4, then we will get 4. If we will put 3, we get 3, 4, and we will put 4, then we will get. We observe that 2, 3 have appeared more than once as first component of the ordered pair. 2, 3 appeared more than once, therefore this is not a. Now check the third one. It is given function 3, that is xy, in that x plus y is equal to 5. Make the first function. If we will put 1, we get 4. If we will put 2, we get 3. If we will put 3, we get 2. And if we will put 4, we get. In this, we see that given set has appeared as the first component in one and only one ordered pair. So this is a function. So we will see about the function in the. Let's move to the next question. Let f be a relation the set n natural numbers defined by function is n and 3n, where n belongs to natural number. Is f a function from n to n? If so, find the range of f. We have to find the range of f. Move to the solution. Here it is given n belongs to natural number. So there exists a unique image of 3n that will be also belongs to natural number, such that n3n is belongs to function. So f is a function from natural number to natural number. So range of f will be equal to, as we get, range of f will be equal to function of n that belongs to natural number. So we will get function as a, and that will be equal to, as the range is 3n and n, so we'll get function as n and 3n, and that belongs to only natural number. This will be the range of the following function. Let's move to the next question. It is given that let f be a subset of z by z, that is integer by integer, defined by f, and function is given that ab, where a plus b, where ab belongs to integer. is f a function from z into z. Specify that f be a function from z into z. We observe that 1 into 6 will give 6 and 2 into 3 will give also 6. 1 into 6 and will be equal to 1 plus 6, and this is a function given, and in this if we see 2 into 3, 2 plus 3, this is also a function. This gives 6, 7 belongs to function, and from this we get 6, 5 belongs to function. So as we see, 6 belongs to 7 also and 6 belongs to 7 also. So f is not a function. F is not a function from z to z.